All right, guys. Everybody have a note sheet. Any questions other than the previous homework assignment? Okay. The note sheet for today. Note sheet for today is a new note sheet.
What? The football practice canceled? Football practice canceled? Dude, no more football practice?
What was actually saying?
Cheerleading.
Don't even do that, Jeffrey. Keep my desk forward.
I think I'm my feet are under me.
All right, guys. Let's focus in here. So, we're going to start the note sheet today. We're going to finish it tomorrow. So we're not going to get through all of this note sheet today. Now, there's two main things we're looking at with these quadratics, and that's vertex and axis of symmetry. And the vertex and the axis of symmetry are helpful if we're going to graph these, especially for graphing them by hand. Now, when we talk about graphing, especially the equation of a line, we needed 2 points. Because if you have 2 points, you can graph a line. For a parabola, you need 5. You need 5 points to be able to graph a parabola. One of those points is the vertex, which is either the highest or lowest point. And then you need 2 points to the left and 2 points to the right of that vertex. Now, the first equation we're looking at, and we've looked at it already, for a parabola is vertex form. This a times x minus h squared plus k. Now, the reason they call it vertex form is because the h and k values are the values of the vertex. H is the x value of the vertex, k is the y value. So if we have it in vertex form, it will really tell us what the vertex is, h comma k. The axis of symmetry is the vertical line represented by the equation x equals h. So really, we have the h and k values. We will have the vertex and the axis of symmetry. So, if we look at this first example, a times x minus h squared plus k is the general form. And if we match the equation given to us, negative 2 times x plus 3 squared plus 4, the value of a, h, and k, well, a is going to be what? Negative 2. H is, it is indeed negative 3, because x plus 3 inside the parentheses, the only way we can get it is if h is negative. And the value of k is 4. And it would indeed be positive. Now the vertex is the point h comma k. So for us here, h is negative 3 and k is 4. So it would be the point negative 3, 4 is our vertex. Now the axis of symmetry, we can shorten axis of symmetry to a of s, but we will need to write out the x equals. Now in the general form, x equals h. And our h value in this case is still, let me see. So we have found the vertex and the axis of symmetry. Those are the two main pieces we needed to find. Now if we wanted to graph this, the first thing we would need to do is plot the information we have so far. So -3, 4. We can plot the vertex first. Axis of symmetry is going to cut through that. X equals -3 is the vertical line of this right here. Now, to fully graph a parabola, we need 5 points. We need 5 points. Now, okay, you need a note sheet. So 5 points. Now, the middle point is going to be the vertex, our -3, 4. And from here, we take 2 points to the right. So we go over 2. So since -3 was the x value, our 2 points to the right, the two x values would be -2 and -1. We also want 2 points to the left. So we'll take the points, x value of -4 and the x value of -5. Now to find the y values, we're going to take these values of x and plug it back into the equation and simplify to find the value of y. Now we can start with -2. So if I plug that into the equation, we'd have -2 times -2 plus 3 squared plus 4. We're just plugging that x value into the equation to find the value of y. Now at this point here, we can use the calculator to plug this in for us. So -3, -2 parentheses, -2 plus 3 squared plus 4 is 2. So it tells us the corresponding y value when x is -2 is 2. At this point here, we can go -2, 2, and I can plot that point. Now we can do the same thing with -1. So we'd say -2 times -1 plus 3 squared plus 4. And we're going to do the same thing. So we type this in, -2 times -1 plus 3 squared. We get -4. So -1, -4. So we plotted 3 of the points. We plotted the vertex 2 to the right. Now we need to find the 2 to the left, -4 and -5. And we'll do a similar thing to what we've been doing. So for -4, we'd say -2 times -4 plus 3 squared plus 4. And again, at this point, I would just grab the calculator and tell it -2 parentheses, -4 plus 3 squared plus 4 gives us 2. And that is kind of interesting because when we went one spot to the right, we got a y value of 2. We go one spot to the left, we also get a y value of 2. What do we expect the y value for -5 to be? Anybody have a guess of what this value is going to be? -4. Because if we plug it in, -2 times -5 plus 3 squared plus 4 is indeed -4. Because as we said, this equation, this axis of symmetry cuts the graph in half. So the points to the left of it should mirror the points on the right, and the points on the right should mirror to the points on the left. And this is kind of nice to know because it tells us if we're going to graph these, I do still need 5 points, but I only actually have to find the value of 3. I find the vertex and 2 points to the right. The 2 points to the right would give me the 2 points to the left, or vice versa. So I need to find 3 of them. And that will tell me what the graph of the parabola is. Now the other way I could have gotten this graph is we could have gone in and said y equals -2 parentheses x plus 3 squared plus 4. And the graphing calculator will also give us the same graph. Now the main thing is there a question on how we found the vertex or the axis of symmetry so far? Let's look at this next one here. A, H, and K. So the general form for vertex form is A times X minus H squared plus K. And looking at this here, what's the value of A? 0.5. What's the value of H? It is 4. Would it be positive 4 or negative 4? Negative, because the only way we can get to X plus 4 is if the value of H is negative. And our value of K is 2. Would it be positive or negative? Negative. So the vertex is the point H comma K. So our vertex here would be -4, -2. H and K. H is -4, K is -2. We replace H with its value, K with its value. What would the axis of symmetry be? X equals H, so X equals -4. Questions on how we found the vertex of the axis of symmetry? Okay. Because just knowing this and that the fact that A is positive, since A is positive, if we were to graph this and just get a general picture, not the exact picture, because -4, -2, the vertex would be this point here. We know since A is positive that it's going to open up. And we know that it should be mirrored across this line. So it gives us a general idea of what it looks like. If I want to know the exact picture, we can either find the points or plug this equation into the graphing calculator and have it tell us what it is. So the graphing calculator will do most of the graphing for us. Yes. This is also why I don't put a big emphasis on graphing these here, because we do have tools and resources that will do it for us. If we can interpret and understand what it's telling us, that's more important. A, H, and K. A here is -3. H is. It is 1, but -1. And k is? Because k would be added or subtracted after the parentheses. Since there's not a number being added or subtracted from it, k is 0. There is no value for k. Vertex and axis of symmetry. And with these here, and especially when we start looking at 2, 3, we need to be paying attention to how these match up to our general form. Vertex is always going to be x, h, comma, k. Our h value in this here is -1. The k value is 0. Axis of symmetry, x equals -1. Axis of symmetry, what's h? Yeah. Guys. Yeah. No, it's just the axis of symmetry, x equals h. So h is going to be, once we have the value of h, we replace it with its value, guys. Questions on this here? Does that make sense? No need for the additional comments? Let's look at one more. 2 times x minus 2 squared plus 5. A, H, and K. So what's A? 2. H is 2. Would it be positive or negative? It would be positive. And K is? And it would be positive. Now the vertex is the point H, comma, K. So for us here, it would be the point 2, 5. Axis of symmetry. X is equal to H, so for this here, X is equal to 2. And that's it. Questions on this here? All right. Standard form comes in the form of ax squared plus bx plus c. Now to get from vertex form to standard form, these here are the steps that we would go about doing it, and then we can reassociate those terms back to a, b, c. Now for the most part, that's not important for how we get there. Now, for a quadratic in standard form, if a is positive, if a is greater than 0, it's going to open up. If a is less than 0, it's negative, it's going to open down. The vertex is going to be given to us by this point here, negative b over 2a, comma, f of negative b over 2a. And the axis of symmetry is given to us by the equation x is equal to negative b over 2a. And we'll look and see how that works here in a second. Now, the other thing that's interesting is the y-intercept in standard form is the value of c. Because the y-intercept where it crosses the y-axis is when x is 0. So for the standard form, if we plug 0 into x squared and into x, well, ax squared would become 0. Bx would also become 0, so that just leaves us with the value of c. So the y-intercept is 0, comma, c. Now, let's actually see how this works. So, we need to line the given equation in standard form to our general form. So our ax squared plus bx plus c is going to correspond with the equation they gave us. 3x squared minus 6x plus 1. So looking at this here, what is the value of a? The value of a would be 3. B would be negative 6. Let's focus in, guys. And C would be 1. A, B, and C. So C is going to be our number without a variable. B is going to be the number in front of x. So here it is 6, but we also take the sign with it. So we would say negative 6. A is the number in front of x squared, which is 3. The values of A, B, and C, when we have those values, none of them are going to have the variable. A will never be 3x squared. It's just the number in front of x squared. B is just the number in front of x. And C is our number without a variable. Now, vertex, an axis of symmetry. Now, in the general form for the vertex, we said it was negative b over 2a, comma f of negative b over 2a. And the axis of symmetry is x is equal to negative b over 2a. So the first thing I want to look at, and the first thing we're going to find a value for is negative b over 2a. So negative b over 2a is the general form for this here. So when we actually factor the vertex form out and compare a, h, and k to a, b, and c, this is how they actually go back together. If you want, we can look more in depth at it later, but for this here, really understanding how we go from it isn't as important at this point here. So to find the x value of the vertex, we need to find the value of negative b over 2a. What is the value of b? Negative 6. So I'm going to put it in place of b. What's the value of a? So really what I want to find the value of is negative 6 over 2 times 3. So negative 6 is positive 6. 2 times 3 is 6 divided by 6 is. So negative b over 2a is. So we have the x value of the vertex, yes? Bless you. We also know what the axis of symmetry is. Axis of symmetry said what? X is equal to negative b over 2a. So here, x is equal to okay. So now the only thing we don't have is this f of negative b over 2a, yes? Well, I know the value of negative b over 2a at this point. It is 1. So at this point, it's really asking us what is f of 1. Yeah, at this point here, all it's saying is what's the value or y value when x is 1. So all we got to do is take that x value and plug it back into the function. Well, 1 squared, 1 times 1 is 1. Negative 6 times 1 is negative 6. We still have our plus 1. 3 times 1 is 3. Negative 6 plus 1 is negative 5. And 5 minus 3 is negative 2. So in standard form to find the vertex in the axis of symmetry, really all we need to find is the value of negative b over 2a. That goes in for axis of symmetry, the x value of the vertex. Take that value, plug it back into the function, and we have the vertex. and that's it. The negative 6 over 2 times 3. Could we have plugged that in the calculator? Yeah, there's no variables. It's all numbers. The calculator could have done that. How about? Yeah. So we could do it by hand or in the calculator, either one. Are we ready for the next one? Yes. So when we look at this next one here, x squared plus 2x minus 1, what would the value of c be? -1. What's the value of b? 2, and it would be positive, yes? What's the value of a? It is 1. As when there's not a number written in front of the variable, it's understood to be 1. If it was 0, we wouldn't have a term there, because we're not going to say 0x squared. Interestingly enough, for quadratics, a is never going to be 0. Because if a is 0, we do not have an x squared term. If we don't have an x squared term, it's not a quadratic equation anymore. So a is 1, b is 2, c is -1. Now we want to find the vertex. And in the general form, it's our negative b over 2a comma f and negative b over 2a. And we also need to find the axis of symmetry, which for this here is x is equal to negative b over 2a. And the first thing we need to find is actually the negative b over 2a. Now looking at this problem here, the value of b is 2. The value of a is 1. So we have negative parentheses 2 close parentheses over 2 times 1. Now at this point here, we can do it by hand or we can stick it in the calculator. Either one works. If we grab the calculator, say negative 2 over 2 times 1, we get -1. So that tells us the x value of the vertex, and actually tells us the entire axis of symmetry for this here. Now the only other thing we have to do is find the y value, and we could do that by plugging this value back in. So we'd say -1 squared plus 2 times -1 minus 1. -1 squared minus 2 times -1 plus 1. Let's make sure I got that written right. I did not. Because that should be -1 squared plus 2 times -1. Yeah. It is -1 in it. Third time's the charm. There we go. That looks better. Now, especially when typing it in with negatives and squaring it, we do need to make sure we have parentheses around it, because without the parentheses, it will indeed give us the wrong answer, because -1 squared plus 2 times -1 minus 1 will give us -4. Because it doesn't see that -1 squared is -1 times -1. It sees it as a negative 1 times 1. It has it as two separate numbers. That's why we do need to put parentheses around it. And especially if you're typing it in and you're plugging a value in, you're not sure if you need the parentheses or not, go on and put them. Because if you have them and don't need them, it's not going to mess anything up. If you need them and don't have them, it is going to change the value. Questions on how we found the vertex or axis of symmetry? We're ready for the next one. ABC, what is A? -2. B is -8, and C is 1. First thing we do need to find is -b over 2a. So we'd have -8 over 2 times -2. This one here, I'll do it by hand. Our -8 is going to be 8. 2 times -2 is -4. So at this point here, we have to divide 8 by -4, yes? Well, it wouldn't need to be -2. We can just say 8 divided by 4 is 2. Positive divided by a negative is still going to be negative. So it would indeed be -2. At this point here, we have 2/3 of the answer. Now we just have to take that -2 and plug it back in. I'll go on and do this one by hand also. Our -2 squared, -2 times -2 is +4. -8 times -2 is going to be +16, +1. 2 times -2 times 4 is -8. We can go on and do 16 plus 1 is 17. And -8 plus 17 is 9. So our point is, the vertex is the point -2, 9, and our axis of symmetry is x is equal to -2. Questions on this here? Questions on what we've done so far? And again, I know we haven't been graphing these, but if we looked at this here, so -2, 9, so we can go to the left, down 9 will be the vertex. We know that the value of A is negative, so it's going to have to open down. So it's going to be going down from there. And because of that, it's not going to cross the x-axis, which means this does not have any real solutions. Let's see here, because it was, no, it does. I'm looking at the other direction. Because it'd be -2, 3, 4, 5, 6, 7, 8, 9. So this would be point here, and it would open down. So we would have two solutions at these points where it crossed. And those points would be our solutions for this here. Most likely, one of them is going to be a positive solution, a positive number. The other is going to be negative. Because it's going to cross the y-axis at 1, which means one of them is going to be on the right side. But we will stop there.